Well, hey, Precalculus, here we go. Section 14.5, the area problem. We're going to be on this one for several days and just kind of looking at the author's take on this, which he doesn't go far enough, by the way. We're going further than the book goes. My take on it, I decided we're going to kind of ease in here. I'm going to take the author's approach for Section 14.5, and then we're going to launch pad into this thing. You're going to love it. You're definitely, okay, you're not, but we'll start here. Here we go. In this section, we're going to find another use for limits. And we will find this to be a very technical, like you got to be good with your algebra and not make mistakes with negatives and such. It's going to be tedious by the time we're done with it, if I can spell that word. And then, honestly, it's going to be weirdly satisfying when you get it right. Like, if you do like a whole bunch of things right and you get this problem right, there's a weird satisfaction to doing that much math and getting it right. Now, we're not doing that today. We're just easing in today. So just work with me. It's a little conceptually weird, but I think you'll find that everything I'm doing is not so hard today. Just follow the directions. For the following graph, we're going to come up with two bad approximations for the area under the curve but above the x-axis between x equals a and x equals b. All right, so what I want to do is I want to go to both of these and kind of put a and b. We're going to try and put them like in the same place. Okay, so there are two x-intercepts. And then I'm going to do my best to draw a similar graph both times. All right, so that's my graph. You guys see it? I'm going to do it again. Do your best to just kind of draw the same graph twice there. Now, I'm looking to estimate the area from A to B underneath this graph. Like this, like if I was shading, this is what I would be looking for, right? And same thing here. I didn't graph it exactly the same, but it's pretty close. Okay, ready? The area of a rectangle can be found by the formula length times width. So what I'm going to do is I'm going to break this area up instead of just one rectangle, which would make no sense whatsoever. If I went up to the top here and drew a rectangle and came back down, it'd be a pretty bad estimate for the area for this thing. So for figure number one, I'm going to divide the distance from A to B into two equal lengths. The distance from A to B, I'm going to try and just go, I'm going to eyeball that there and go halfway. Okay, now using the left side of each of those two lengths. So for this one, I'm going to use that side. And for this one, I'm going to use that side, the left side of the interval on the x-axis. I'm going to draw a vertical line segment from the x-axis to the curve. Okay, so for this first half, I'm going to go to the left side. I'm going to draw a vertical line that goes up and hits my curve. Okay, and then for this side, I'm going to draw a vertical line that goes up and hits the curve. Okay, use that height, the one on the left side, to create a rectangle over the interval. Okay, so I'm going to go across and bring that down. And then I'm going to go across here until I hit where B would be, and I'll bring that down. Okay, I used the left side. There's an interval, we'll call it interval 1 and interval 2. For interval 1, I went to the left side, and I went all the way up until I hit the curve. I went straight across and brought it down to finish off the interval. For interval 2, I went the left side up till I hit the curve. I went across, and I made a rectangle. Do the same with the second interval. Did it. Nailed it. Number 5, shade the area of each rectangle. Okay, you ready? Watch this. So I'm going to shade this area, all of it, and I'm going to shade this area. And what I'm saying is that my shaded area is an estimate for the area under the curve and above the x-axis. You and I can both agree that that is a poor estimate. It's way too big. My estimate is way too big. Okay? Now, I'm going to repeat the process for figure 2, where I tried to draw the same thing. It's not perfectly the same, but it's close. But I'm going to use 4 intervals. Okay, so watch. I'm going to cut this thing in half, right there, eyeballing it, of course. And then I'm going to cut it in half again so that I have 1, 2, 3, 4 intervals. Everybody okay? I don't know why I keep asking. You can't answer that. Then I'm going to repeat the process. So I'm going to use the left side again. We don't have to use the left side, by the way. We can use the right side. But I'm going to use the left side. So I'm going to go all the way up until I hit the curve and I'll stop. So this one I'll go up until I hit the curve and I'll stop. Now this one I go across and I complete that rectangle. Now this one hit here, so I cross until I'm this tall. So that one goes up and I'll stop right there, right? But this comes over and I got to finish this rectangle because I went up on the left side. That's how tall it is. Now this guy right here, it hit here, so I'll go across and then bring it back down. And this one hits just a little higher, go across and then bring it back down. So now instead of 2 rectangles, now I have 4 rectangles. And with all 4 of them, I did the same thing I did with both of these. I went on the left side of each one of these numeral numbered intervals, and I went up until I hit. So I'm going to shade. There's shading interval number 1. Interval number 2 is way too big. Interval number 3 is actually pretty close to the truth, and interval number 4 is actually too small. See what I mean? That area is too small. I missed some, but here I got some extra. So if I were to ask you, as if you're an idiot, hey, which of these 2 is a better estimate, you would go that one, right? Okay. So there's our idea. I'm going to find the area problem. I'm going to find the area under a curve by using rectangles. But can we agree that if I use more rectangles, there's less error? And so it's closer to the truth. That's what I wanted you to get it from page 1. And also the idea of breaking this up so that they're equal lengths. And please note that we did use the left side. I could have done this adventure on the right side. And if I did, this first one would only go this high and would go across. It'd be too small. And the second one would be way too small. So instead of being way too big, the answer would be it's way too small if I use the left side on both of these. All right, I'm going to go to page 2. There we go. Try and make sure I stay in your frame here. How'd I do? Is that good? Right there? That good? All right. No, just missed a little bit. There we go. Now, if we knew the equation, if I didn't just draw a curve, if I knew the equation for that curve, we could actually substitute in an x value on the left side of the interval, and then we would actually get a y value that would represent the height. You know what? I'm going to go to my notes, and I'm going to bring my notes back over here so I don't have to flip your page over. But look, if I actually knew this was like fx equals, like x to the third plus 5 or something like that, and if this was like a 2, I could put 2 into that equation, and I could get a y value here. It would be f of 2. See what I mean? And so I could find the area of this rectangle because that height would be the length of my rectangle. And these are all the same, so I could find out what that is pretty easy too. And I could just add up my 2 areas. So that's where we're heading for sure, guys. So if I put an x value in, I get a y value. That would be the height, which is the actual length of our rectangle for area equals length times width. We're going to consider the height that goes up to hit that curve to be the length of every rectangle. If we knew what A and B were, we could also easily find the length of each interval that we create on the axis. Basically, wouldn't it go, let me bring the picture back in here, but I mean, don't you find this distance by going B minus A, right? B minus A. Well, that would be this length right here. And if I cut it in 2, just divide by 2, and I'd actually have that number right there. If this was like 2 up to 9, if this was 2 up to 9, I would subtract them and I go, hey, this is 7, and I made 2 intervals, so that's got to be 3.5, and that has to be 3.5, right? So I could find those pretty easily. Those would be the width of our rectangle. So I got a length and a width. Then we could find the area of each rectangle, and we could just add them to make an approximation for the area. Now, I think you and I will both agree that the approximations that we made were not very close. One was way too big, one was a little too small. But if we made it more rectangles, we'd be in business. Approximating the area under the graph. So I'm actually going to give you an equation here, and we're going to go from x equals 0 to 1. Okay, let's draw this in the first place. So I don't want this to be scaled like this is 1, 2, 3, 4, 5. We're going to make this a little easier on ourselves. Watch, I'm going to go 1, 2, 3, 4, 5. I'm going to go 5 out, and then it goes 6, 7, 8, 9, 10. That's going to be a 1 right there. and all the way out to 10, that's going to be a 2. I'm scaling this real big so that we can blow up the picture a little bit. So I'm going to go up 1, 2, 3, 4, 5. And I'm going to call that a 1, and then 1, 2, 3, 4, 5, we'll call that a 2. So we're zooming in on this a bit, right? I'm going to graph the line y equals 2x. Well, y equals 2x goes through the origin, and then it goes up 2 and over 1. So that's the graph of my line. So I'm going to get a ruler, which is left out from a few days ago, just sitting on my desk with nothing to do. And there's my graph, right? There is y equals 2x. Feel free to pause and get your own ruler and do that if you want. But now look, you guys, if I'm going from 0 to 1, and I'm going for the area under this curve, isn't it a triangle? Like, isn't this a triangle with a base of 1 and a height of 2? And let me just go over here to the side and go area equals 1/2 base times height, which is how I find the area of a triangle. So it's 1/2 times the base is 1 and the height is 2. The area equals 1, doesn't it? And let's call it units squared. I just wrote on my desk a little bit. Oh well. Okay. I'm purposely using something where I know the area to prove a point, guys. Like, we could just go, hey, I'm done, let's move on. But I want to keep using rectangles so that you guys get a better feel for this and see how we're estimating it, and, you know, kind of badly. So here we go. We're going to partition the interval 0 to 1, which, let me point it out, 0 to 1. This is the area we're looking for. This is this rectangle right here. None of this over here. Into 2 smaller intervals of equal length. So if I'm going from 0 to 1 and I want to break it into 2 smaller intervals, I go halfway. And that's a 1/2 right there, isn't it? Okay, use the left endpoint again. That's what we did on the last one. Of each interval, use f of x. So I'm actually going to put the left interval into this function, y equals 2x, and get a value. And then use the width to find the area. Okay. Well, the first one's kind of weird, because here's my width right here. My width is definitely 1 minus 0 is 1, and I'm divided it into 2. So my width is 1/2. So I'm just going to write that over here. W equals 1/2. Now, for the height, it says use the left interval. Well, the left interval is 0. And I mean, I can see that it actually strikes this thing right here. But I'll play along with the process. I need to find f of 0, so put 0 in. 2 times 0 is 0. So what I have right there is actually the height of my rectangle. It's not going anywhere. Ready? So over here, I want to do this. I'm going to put f of 0, the left part of the interval, and I get 2 times 0 is equal to 0. Yeah? Okay. And I know that the width is 1/2. So here we go, guys. Area equals length times width, because it is a rectangle. It just doesn't have any height. So that's going to go 0 times 1/2. It's equal to 0. That's my rectangle right there with no area whatsoever. I am way underestimating right now. Okay, now let's do the second one. The left part of this interval is 1/2. So 1/2 goes up and it hits right here. There it is. And then I'm going to go across to finish off my interval. And because the first one was kind of a letdown and had no area, this is going to have to carry the whole thing. This will be my estimate for the area under this curve. It's going to be terribly small. But let's put in f of 1/2. The reason I'm putting 1/2 in is that's the left side of this interval. The left side of this one was 0. I'll put a 0 there. The left side of this one is 1/2. I put 1/2 into the function, and I get a y value. That's the height of this rectangle. So I'm going to go 2 times that x value of 1/2, because that's my equation, 2 times 1/2. And I get 1. So my area will be length times width. It's going to be that 1. This width is also 1/2. And so I get a 1/2 right here. Now here's how I find my area. I add up all my rectangles to make my estimate. So area equals 0 plus 1/2 is equal to 1/2 units squared. That's my estimate for the area under the curve. Now you and I both know it is much bigger than that. That is a terrible estimate. But I want you to get used to the process. More than anything, I want you to see that I put this x value into that function and got a y value which gave me a height and turned that into the length of my rectangles. That's really important for us for the next few days. Bad estimate, not even close. I missed it by 50%. Okay, we're going to approximate the area, y equals 2x again, same one. we're going to go from 0 to 1 again. But here's the thing. This time, I'm going to partition the interval 0 to 1 into 4 smaller intervals of equal width. So where I had 2 things here, I'm now going to have 4 things. I'm going to add up 4 areas and see if we can't get closer. Ready? Okay, so I go 1, 2, 3, 4, 5, and I make a mark. That's 1. 1, 2, 3, 4, 5. All the way at the end is 2. I go up 1, 2, 3, 4, 5. That's a 1. And go up here. That's a 2. I go up 2 and over 1, and I start at 0. Let me draw with my cool ruler. Let me draw my line again. Get everything all lined up. There we go. There is y equals 2x. That's my function. Now I'm going from 0 to 1, and I'm supposed to divide it into 4 equal areas. Okay, divide it in 2. There's 1/2. Now divide each one of those in 2. So when I cut this off, that's going to be 1/4. And when I cut this in half, that's going to be 3/4, isn't it? Okay, use the left endpoint again. So when I do this first one, I'm going to put 0 in. It's going to be a waste of time again. But now I've got a couple more left endpoints, and let's see how closer we get, how much closer we get. Use the left endpoint, put the left endpoint in for x, put it in this function, multiply by 2 and get a y value. That will be the length of the rectangle. Now the width of the rectangle this time, it starts out from 0 to 1, so I go 1 minus 0 to get that length, which is just 1. But I divide it by 4, and so this time the width isn't going to be 1/2. The width is this time going to be 1/4 because I made them smaller. Okay? Here we go. The first one. I'll put a little number 1 there. I need to find f of the left endpoint 0. Okay, this is a waste of time. This is 2 times 0. It's equal to 0. That's the length. So my area is supposed to be length times width. It will be 0 times, my width is 1/4. I get 0 for the first one. No help there whatsoever, but I'll draw my rectangle, which has no height whatsoever. Number 2. Well, the next one is this interval, and I'm going to put in f of 1/4. Okay, I'm going to take 1/4 here, and I'm going to go up until I hit this thing. I'll go across and finish off my interval, and I'm going to shade. That shaded area is what I'm about to find. So it goes 2 times 1/4. I get a height of 1/2. This height right here is 1/2. You can kind of see it visually. It looks like it's about 1/2, doesn't it? Now that's the length of my rectangle, and the width, of course, is 1/4. So I go area equals length times width. It's going to be the 1/2 that I just found times the 1/4, and 1/2 times 1/4 is 1/8. I have 2 areas so far, a 0, because I'm a loser, and then a 1/8, which is getting me closer. It's still too low, though. All right, interval number 3. Now, for this interval, I'm going to put the left end, it's going to be 1/2. So I go f of 1/2. Well, I put that into the function, which is just 2x. And so I go 2 times 1/2 is equal to 1. That's the height of this rectangle. So let's draw it. I'm going to go up. I'm going to hit this thing. Should be at 1. I'll go over and go back down to where 3/4 is. Now I'm going to shade that in. I'm about to find that area. Okay, that area goes length times width. So it'll be the one that I found times 1/4 is my width of all of these. They're all 1/4, and so I get another 1/4. I got one more interval to go. I should have 4 intervals because I made it 4 intervals, yes? Okay, so for number 4, it will be f of, what's the left side of this interval? It looks like 3/4. So I go 2 times 3/4 because I'm putting that x value into this equation, which is 2x, and I get 3/2. Or 1.5, right? 6/4, or the 2 cancels with the 4 and I get 3/2, any way you want to look at it. So now my area is going to be 3/2 times 1/4. That will be 3/8. Let me draw it. Take this up and you get 3/2 and you go across, and now I have this rectangle. Now you can tell I'm still going to be underneath. My answer will not be right, it'll be small. But won't it be better than that one? Because I did twice as many rectangles. You guys see the big point we're heading towards here? More rectangles means skinnier rectangles means closer to a good estimate. I guarantee you it's going to be better than 1/2. The answer is 1. We're going to be closer than the 1/2 this time. So my area equals 0 plus 1/8 plus 1/4 plus 3/8. Well, that's 2/8, right? That's 2/8 5/8, 6/8. So right now I have 3/4 units squared. It's still too small. It's not a good estimate, but it's better than that one because I used more rectangles and they were skinnier. See my point? Let's go on to the third page. Oh, there's a lot of room on this page. What are we getting into here? I'm going to approximate the area under the graph of, oh, look at this, y equals x squared. That's not a line anymore, that's a parabola. So we can't use the area of the triangle and just know what the answer is. We're on our own here. We just got to estimate. Now, not only is it from for x squared, we're going to go from x equals 1 to 5. So we don't even have the origin to work with here. Okay, let's graph what we have. I think since we're doing a parabola, I don't think we want to, rescale this. So there's a 0, 0 on y equals x squared. There's a 1, 1. If I put 2 in, I'm up to 4. If I put 3 in, I'm up to 9. If I put 4 in, I'm way up to 16, which is going to be way up here, right? Put a -1 in, you get -1. Put a -2, you get -4. You guys got an idea of what the graph looks like. Do you like how I just gave you the first quadrant to draw? I'm starting to make things easier for you guys. Use some tech. Okay, so I'm going from 1 to 5. Well, let me put a 1 here. 2, 3, 4, and this is 5 right here. I'm trying to estimate this area. If I draw straight down here and went this, that would go all the way up to 25, way up there. So I'm trying to find that area. Okay, but the directions are, I'm going to partition this interval 1 to 5, which is a length of 4, by the way, isn't it? 5 minus 1 equals 4, right? Right now, it's a length of 4 from 1 to 5. I'm going to partition that into 8 smaller intervals. Okay, so guys, we got to find 8 different things and then add them up. That's what we just learned. And we're going to use the right endpoint this time, not the left endpoint. So it's going to be a little weird from the first page. Okay, here we go. Well, let's find out what the length of all these are. In the first place, I go 1, 2, 3, 4. So if I cut it in half, it's right there. It's at 3, right? I start at 1, 1, 2, and then 1, 2. If I cut it in half a second time, I have 4 intervals. And when I cut this in half, again, I'm going to be at 1/2 and 2, and 2.5 and 3, and 3.5 and 4, and 4.5 and 5. I'm making some seriously skinny rectangles here. Agreed? Okay, but if I divide this by the 8, I'm dividing that 4 units that the interval is into 8 different pieces, I get 1/2. So my width this time is going to be 1/2. All right, you guys okay with that? Here we go. I'm using the right side. So I'm going to go to the first. I'll put a number 1 up here. I'm going to go to the first interval. It's from 1 to 1.5. And my job is to put in the right side of the interval because that's what the directions told me to do. So I'm not going to put 1 in. I'm going to put 1.5 in and go up until I hit this curve. See what I'm doing? And then I'm going to go over the curve and go back. And I'm going to shade in. That's my first rectangle. It's going to be too big. I'm on the right side when I'm putting this in, so it's going to be too big. So I'm putting 1.5 into that function. So here we go, guys. F of 1.5, well, that's equal to 1.5 squared, right? Put 1.5 in here and square it. That's equal to 2.25. All right, so guys, my area, which is length times width every time, will be the height of the rectangle, 2.25, times the width of the rectangle, which we just found out was 1/2. 2.5 times 1/2, I put that in my calculator earlier today, is 1.125. That's my first area, and that's the representation of it. Let's go to do number 2. We got 8 of these, guys. So stick with me. I'll go a little faster once I feel like I've explained it okay. The second one goes from 1.5 to 2, and I'm supposed to use the right side. So I'm going to take 2 up here, it goes up to 4, then bring this down. I'm going to shade that in. I'm over shading. It's really dark now, but I got to put a 2 on the right side of this interval in, and I get 2 squared is 4. So I got to find f of 2, which is 4 when I square it, because that's the parabola that I'm working with. And so my area will be 4 times 1/2. That's the math Larson likes to do. That one's equal to 2. Let's move on to interval number 3. There will be 8 of these. I'm going to go to the next one. It'll be 2.5. So let me draw 2.5 going up through this until I hit this curve. I'll go over, and then I'm going to shade in my rectangle. I put in a 2.5 in for x. So f of 2.5, the right side of that interval, 2.5 squared, put this in my calculator earlier, is 6.25. So the area of my third rectangle is the height, 6.25, times the same width, 1/2, and that ends up being 3.125. I now have 3 rectangles, and I'm building up to getting closer to finding the area of this thing. The last one I put in was 2.5, so I'm going to go to the next right side, and that'll be 3. So I'll just follow this 3 up until I get all the way up here to 9, and that's my next rectangle. Pretty tall. Okay, so this will be number 4. I'm halfway there when I'm done with this. F of 3, put it into this equation. 3 squared is 9. Well, that's the height that gets me up to the top of this rectangle. So the area of this rectangle is 9 times 1/2. So area equals 9 times 1/2. That's 4.5. All right, I'm going to have to stop drawing rectangles because I'm going to get way off of this graph, but I'll go 3.5. I'll go up until I think I'm hitting this thing. It's way up here. That's going to be the last rectangle I draw, I think. We're going to go like this. Number 5 is f of 3.5. When I put 3.5 in my calculator and square it, I get 12.25. Hey, Christmas. And so area equals 12.25 times 1/2. That ends up being 6.125. Okay, I'll do number 6. I'm going to pick up the speed here because I think you guys got it. Now I'm going to put in f of 4, which would be the right side of the next interval. Well, 4 squared is 16. I know that one. When I put a 4 in and square it, I get 16. So my area is 16 times 1/2. I know that too. That's equal to 8. Do the 7th interval. Do the right side. This time I'm putting in 4.5. 4.5 squared to figure out how tall my rectangle is. 4.5 squared is 20.25. And so area equals 20.25 times 1/2. That's going to be 10.125. And then number 8, the last interval, when I get to the right side of this one, will actually be 5, where I'm supposed to end my journey anyway here. 5, put in here, 5 squared is 25. And so my area is going to be 25 times 1/2. That is 12.5. So now that I did 8 skinny rectangles, you got to see the picture. Like, this is going to be a better estimate than either of any of the ones we did so far. So I get out my calculator and I go 1.125 plus 2 plus 3.125 plus 4.5 plus 6.125 plus, I'm just going to put dots and go to 12.5. I put all of this in my calculator and added it up, and you guys, I got 47.5 units squared. And you have to admit that even though these are all a little bit over, that's going to be the best estimate we've had so far today, right? So I'm going to have you do a couple of these for homework. I'm going to have to read through, think through, but be very careful to see, are you using the right endpoint or the left point? Because it's on my math lab, and if you don't use the correct side, you'll get a different answer. All right? More about this notation thing coming up later, but the name for what you just found is called the integral for f of x equals x squared from x equals 1 to 5. And the symbol for an integral in math looks like this. It's like a tall, weird, skinny S. We put a 1 down here and a 5 up here. Those are called the limits of integration. Getting into some serious math stuff here. We put x squared because that's what our expression is with respect to x. That's how that goes. The integral from 1 to 5 of x squared with respect to x. And I'm not going to put equals because I know that my answer is not right. It's approximate. So it's approximately equal to 47.5 units squared. All right? Here's a question. Nobody wants to do this because doing 8 of these took a while. But what if I made this 200 rectangles? Wouldn't there be less and less error, and wouldn't that be even closer to the truth? I think my answer is too big here. I think you would agree with that. What if I made it 1,000 rectangles? Think about that before we get into business tomorrow. All right, your homework is on my math lab. It's not very many of them. Make sure and take a good look at these notes and try your few problems for homework. Have a good night.